Hey everyone, welcome to this explainer. Today, we're diving into a massive breakthrough in the AI world that completely rethinks how we fit intelligent agents right into our pockets. We're looking at a brand new framework called Core, and it tackles this massive problem of fitting large context windows onto everyday mobile devices. So, if you've ever wondered why your smartphone can't seamlessly read a huge stack of documents locally without absolutely melting the battery, well, you are going to love this. We've got a lot of fascinating technical ground to cover today. Here's the roadmap. First, the rag blow problem, then why SLMs are kind of a flawed fix, introducing Core, how it actually works, and finally, those real-world results. Let's get right into it. All right, part one, the rag bloat problem. So we all know retrieval augmented generation, or RAG, is absolutely essential for getting accurate AI answers. But here's the elephant in the room. How on earth do we fit all that massive AI context onto a smartphone? Feeding thousands of retrieved documents into a mobile device's AI is physically constraining. The hardware just isn't there yet. And that brings us straight to what we call rag bloat. When you pull in documents for an AI to read, it's incredibly noisy. In fact, over 95% of that retrieved context is completely redundant or just irrelevant. Think of raw rag context like going on a simple afternoon hike, but you're carrying a giant 100-pound backpack filled with every tool you own. It just completely exhausts the device. Your poor language model is forced to crunch through tens of thousands of tokens just to find one single tiny fact. Moving on to part two, small language models and why they're a flawed fix. So the industry obviously saw this problem, and their go-to fix was prompt compression using small language models, or SLMs. Current frameworks like LLM Lingua use these SLMs to sort of pre-read and compress the context before sending it to the main AI. But here's the catch. These quote-unquote small models still require serious GPU and CPU power. A 7 billion parameter SLM can eat up to 14 gigabytes of VRAM just to run. On top of that, asking an SLM to pre-read 10,000 tokens causes severe pre-filling latency. Going back to our hiking analogy, it's essentially like hiring a slightly smaller hiker to carry that giant backpack for you. You're still going to have a massive traffic jam on the trail. Which brings us to part three, introducing Core. This leap forward is just brilliantly simple. Look at this comparison. The old method eats up around 14 gigabytes of memory and introduces crazy high latency before the main AI even starts answering the user. Core, on the other hand, eliminates the auxiliary SLM entirely. It drops the memory requirement drastically to under 2 gigabytes, and it speeds up the whole pipeline so it runs lightning fast. It's literally a game changer. So what exactly is it? Core stands for Context Refinement via Entity-Aware Filtering. Simply put, it's a two-stage sentence-level prompt compression method. And the secret sauce here is that it relies entirely on heuristics, structural and semantic rules, not generative models. Instead of using a secondary power-hungry AI model to read everything, Core uses a super lightweight deterministic filter. It's like dropping the heavy backpack and just bringing a Swiss Army knife in your pocket. All right, let's peek under the hood. Part 4, How Core Works. Core's superpower really lies in this clever two-stage process that cleans up the information before it ever hits the main LLM. Stage 1 handles entity and clue extraction, and Stage 2 handles refinement and combination. Let's break down what happens in each. Okay, so in Stage 1, Core uses these really lightweight tools to scan the text for concrete facts, things like names, dates, and locations, using named entity recognition. That forms what they call the answer set. At the exact same time, it uses semantic matching against the user's query to find sentences that logically support those facts, creating the clue set. Basically, Core figures out the who, what, where, and the why or how, and it does all this without needing a heavy language model to interpret a single thing. Then we hit Stage 2, where it aggressively chops out the fat. It uses something called orthogonal residual retrieval to minimize semantic redundancy. Basically, if two clues are saying the exact same thing, it tosses one out. Then it uses a spatial proximity metric to filter out topically distant answers. That's just a fancy way of saying if an entity is found 10 paragraphs away from any relevant clue, it's treated as noise and discarded. Finally, it bundles only the absolute most crucial text into a lean prompt that fits a strict token budget. Now for the best part, Section 5, Real-World Results. Theory is great, right? But practical application is what really matters. Researchers deployed Core on 2 hardware testbeds, an NVIDIA Jetson, which is an edge device like you'd find in an autonomous car, and a standard Huawei smartphone. They gave it a super strict limit of just 2,000 tokens to work with, and the empirical results are just absolutely staggering.
First off, accuracy. Working within that tiny budget, Core actually improved answer accuracy by over 30% compared to state-of-the-art baselines. 30%! It beautifully proves a core concept in data processing. Less noise means better focus. By aggressively stripping away the distracting fluff, the language model can actually reason much more effectively.
Second, let's look at memory. By completely ditching the SLM, Core slashed peak memory usage by over 50% compared to the competition. Cutting memory usage in half frees up a massive amount of RAM. That means your phone doesn't have to freeze up all your other apps in the background just to process a complex AI task. And third, and you'll definitely love this if you hate carrying a phone charger everywhere, it cut energy consumption by nearly 96%. To put that into perspective, just look at the raw wattage on the smartphone. The LLML Lingua 2 setup was devouring over 10 watts. Core, it sips just 3.72 watts during its operation. So asking your mobile AI a complex question that requires document retrieval isn't going to nuke your battery in 5 minutes anymore. It is a tremendous leap in intrinsic energy efficiency. Finally, let's talk speed. Core delivers nearly a 2x overall speed up on edge devices. But the most mind-blowing stat here is the time to first token. Because the prompt is so perfectly compressed locally, the latency from asking a question to getting the very first word back drops from a painful 3 minutes down to under 20 seconds. From 186 seconds to 19. That is huge for mobile users. So, this whole breakthrough proves that sometimes the best solution isn't just throwing more AI at a problem. Sometimes you just need smarter data filtering. It leaves us with a really fascinating question to consider. If we don't actually need heavy language models to compress our prompts, what other massive AI bottlenecks can we completely bypass just by returning to targeted, highly efficient algorithms? Thanks for joining this explainer and keep exploring the incredible optimizations happening out there on the edge.